So next what we're going to do is something called trigonometry. You will notice that we've skipped section 4.2 technically, and we've gone to 4.3. I just reordered these. It makes more sense to do 4.3 first. Now the focus in trigonometry is really basically three trigonometric functions, which I will be defining more in a little bit, but just to kind of refresh your memory, what's really going to come up a lot is something called sine, cosine, and tangent. Like I said, you've probably seen these before, and we're going to talk more about them. But first, I want to remind you all really quickly about right triangles. So let's just talk about right triangles for a moment. And right triangles are really good. It's really good to start trigonometry with right triangles because I find it's just a little bit more intuitive. So let's just go ahead and make a triangle. Remember, a right triangle just means that one of the angles is 90 degrees. It doesn't really matter where you put it. And then we have an angle over here. I'll call this one theta. And then we also have an angle up here. I'll call this one phi. And it's important to note in this triangle that theta plus phi will also be 90 because the angles all have to add up to 180 degrees. Now, in this format, we'll start off just by calling these sides A, B, and C. It's important to note that A and B are interchangeable. It really doesn't matter. These are called the legs of the triangle. It really doesn't matter which one you call A and B for the most part. C, however, is important. C is called the hypotenuse. Hypotenuse. And C, in this case, in all the formulas I use, C is the hypotenuse, and this just means the longest side. Sorry, that doesn't look great. Let's go ahead and rewrite longest side. Okay. Now the first formula I want to mention or remind you of is the Pythagorean theorem. Pythagorean theorem. Pythagorean theorem. So this is not trig. This is actually from maybe middle school math. I'm not quite sure when this is first introduced, maybe geometry. But basically the Pythagorean theorem says that a squared plus b squared must equal c squared. So just something to keep in mind throughout this unit. We'll be finding missing side lengths, and we will use this. So hopefully that's review and you remember what I'm talking about there. All right, so let's switch gears back to trig now. And I'm actually going to do sort of the same right triangle, except I'm going to label the sides a little bit differently. So I'm going to call this theta. I'm going to call this side over here the opposite side of theta because it's across from theta. The side down here is going to be called the adjacent side because adjacent means right next to it, and it is right next to it. The other side that is next to it is not called adjacent because that actually has the name hypotenuse. And so now we have our setup for theta. And so basically the way this works is we've defined three different trig functions, sine, cosine, and tangent, and we say that sine of theta is the ratio of whatever my opposite side is over my adjacent side. For cosine of theta, we get the, oops, sorry, that is a major typo right there. For those of you going, what the heck? This should have been hypotenuse. For cosine, it's the adjacent side over the hypotenuse. And then for tangent of theta, this is opposite over adjacent. And there is a helpful mnemonic for this. You might remember so, ka, toa, and that can help you out. So it just basically is, the first one is sine and then it's opposite. So we have sine and then we have opposite and hypotenuse, and I'll let you figure out the rest of them. Now there are also three reciprocal functions. So we often talk about the 6 trig functions, and these are the other 3, so in total we'll have 6. These should all be highlighted in your notes somewhere. So sine goes with something called cosecant. So if you see CSC of theta, you take your fraction and do the reciprocal, so this would be hypotenuse over opposite. Cosine goes with secant of theta, and I'll spell all of these out in just a moment. And so I'm really just taking these fractions and I'm just taking the reciprocal there. And then tangent has cotangent of theta. So spelling these out, this one is secant, this one is cotangent, and for sine it's cosecant. So sometimes students do forget which one is which. Notice how sine has a cosine. Well, it's the same with secant, which has a cosecant, but they just switch. So sine goes with cosecant, and then cosine goes with secant. So each pair of functions, so sine and cosecant, each one has a co. So for example, cosine already has the co, so it must go with just secant, whereas sine does not have a co in it, so it goes with cosecant. All right, so essentially what this means is, let's just say I had a triangle. And I'm going to say that the angle in this triangle is 39.1. Sorry, that was a different problem. 36.9. So this angle is 36.9 degrees, roughly. And then this side over here is 3, the hypotenuse is 5, and the adjacent side is 4. And so then if I said, well, what do you think sine of 36.9 would be? You could say, well, it's the opposite side, so over there is the opposite over the hypotenuse, which is 5. Or I might say, what is secant of 36.9 degrees? And you could say, okay, well, so secant, come up here and check, goes with cosine. We need the hypotenuse and the adjacent side. So this is going to be 5 over 4. And this actually holds true. So if I did a larger triangle, so let's just say this angle is still 36.9 degrees. And this triangle is going to be similar to the previous one. So let's call this 9, 12, and 15. Notice that even if I switch gears here and I say sine of 36.9 degrees, I still get the same answer because 9 over 15 is equivalent to 3/5. So remember, these functions give you ratios. The triangle itself could be different, right? These triangles are different triangles, even though they are similar. If you forgot what the word similar means, just means that one has grown or shrunk. But the ratio, the trig function, stays the same. You can also check this on a calculator. So let's go ahead and take a look at my scientific calculator. Now, one thing you're really going to want to pay close attention to, I'm going to click on this a couple times. I'm switching between, currently I'm in degrees, and I can switch to radians as well. So if I do sine here, there's a nice easy button for that. And if I went sine of 36.9 degrees, this was rounded a little bit, so it's actually 0.6. 3 over 5 is pretty close to that. So I did round a little bit in my example problem, but it is about 0.6. Alternatively, you could do for, let's see here, for secant, what you're going to do is just say 1 over cosine. So we're now taking the reciprocal, and I get 1.25, which is about 5/4, right? So I was rounding here. Technically, wasn't exactly correct. But that's how you do it on the calculator. Now, if I switch to radians, notice how now this is all wrong because the calculator thinks you're saying that this is 36.9 radians, which is kind of a weird amount because 2 pi radians is 1 full rotation, if you remember from the previous video. So 6 radians, 6 1/4 radians is 1 full rotation. 36.9 radians is, I don't know, about 6 or 5.5 rotations around the circle, so that's kind of a weird angle. You wouldn't really find that in a triangle. However, what you could do is you could say, well, 36.9, if I want to convert that into radians, I could go 36.9 times pi over 180. And now you could plug that into the calculator. So sine of 36.9, excuse me, pi over 180. And notice we do actually get about 0.6 here, because I'm now in radians, right? I've switched from radians to degrees, so I do get that 0.6. If I switch back to degrees, now it's again weird. It doesn't really make sense. But just be careful when you're doing trig. Make sure your calculator is either in radians or degrees mode. Okay, and so we'll go ahead and end that video there. That's just kind of a quick little intro. In the next few videos, we'll actually start solving some problems.